Alright guys, so this is the Applied Data Science course that is taught by the University of Texas, and here we are teaching it as a MasterClass with a focus on practitioners. So our purpose of this class is not to teach all the details about data science, but it is to take specific problems and then apply data science to try to solve that problem and apply the right part of data science and the right algorithms within those sections. And so as a result of this class, hopefully we should be able to go and start pulling off data sets either at our jobs or at school, and then start making the right types of decisions based on that. So from a high level, if we were to look at data science overall, this is kind of how we would want to look at it. So if we see data science as a whole, and some of you might already know this, but I want to talk about what we're going to cover in this class. Okay, so we have data science as a whole. We break it into three parts. The first one is we want to use data to figure out what has happened. Okay, so this is what has already happened in the past, what is happening right now. So this is the first arm. And then the second arm is what would happen if everything stays the same, right? So if history repeats itself, what would happen again, right? So here we're going to call it what would happen in future. And then the third arm is if we want some desired objective, so what should we do to achieve a desired objective, okay, in future, right? So for example, maybe some type of event has happened already. So we're talking about maybe there has already been a spike in demand for the products that you're selling, or there has already been a weather event of some sort. So that has already happened, and we are going to. So that's what what has happened will show. And what would happen in the future is we're going to say, okay, based on that, we're going to predict what the demand will be in future, right? So we're going to talk about demand in future. And here we're not going to really be talking about demand. We'll say, okay, given this demand that happened already in the past, in the future, given our forecasted demand, what should we set our capacity to be able to meet that demand, right? What is that set capacity? Okay, so the names that the industry has given for each one of these, this is what is called descriptive data science. This is called predictive data science, because you're trying to predict something in the future. And then this is called prescriptive data science. So here we're just in what has happened. We are just pretty much describing it using data. And here we're using that to make a prediction. And then finally here we're trying to make some sort of actionable decision based on it. Okay. So in historical terms, this descriptive data science is also goes by, you would learn some of it in probability and statistics. You would also study some of this in what is called data mining. And then in industry, business intelligence, the whole area of taking data and making interpretations about what has already happened. A lot of visualization comes also into play here, and then On the predictive side, this is what we today call machine learning. Now, there are others to make predictions, other ways to make predictions also. So let me put those in first. So you can make you can make predictions in the future using analytical models if you have them. So, for example, physical models or physics models, you already have a calculation for something, or if it's a curve fit, and if you already have a fit for that curve, you already have a model for that curve, then you'd use the analytical model. If an analytical model does not exist, then you might be able to create a programmatic model. So a programmatic model basically says, okay, I know all the rules and I can apply that and write some code for that. So I might have a bunch of if-then statements. I might have some calculations and then some if statements around that to say, to give you kind of how to go from the input to the output. But if I can't write the code, or if there's no analytical model and I can't write code for it, then I go into, I may be able to build a simulation model. So I say, oh, you know what? I can't, there's no analytical model for it. I can't write code directly for it, and because the ranges are too much, but I do know something about the distribution about the ranges. And so if I was to provide those as inputs, then I might be able to build a simulation model and then just see what the outputs might be, right? And then if I can't even do that, that is when we go into a learning model. That means you say, you know what, none of these apply, none of the first three apply, and so I really have to go into a learning model, and this is what we call machine learning today. Okay? So I'm using historical information to model what's going to happen in the future, and I don't already have an analytical model. I can't program it myself. I don't have all the rules. I can't build a simulation model for it, again, because I don't have all the rules. And so I'm purely going to make a lot of assumptions that history is going to repeat itself, and I'm going to try to get the model to learn the rules by itself. Okay. And then finally, on the prescriptive data science, so this is one of the hotter topics. It was pretty hot about 20 years ago, and it's becoming hot again. This is where decisions are being made. So you might hear of roles in companies called decision scientists now, not data scientists. And they are actually people who are working on this prescriptive data science, which is saying this is what you should do, right? This is what you should do to handle the predictions that were made here. So this has been known in the past as operations research, and so this is where decisions are made. Okay. So in this class, what we are going to do is we are not going to focus very much on the descriptive side here. We're also not going to focus much on the prescriptive side. And even within predictive, we're really only going to, focus on this part of it. Okay. So we're really only going to talk about this part, but then I'm going to add a little bit of visualization there, and I'm going to add a little bit of prescriptive modeling in there, just so we know where does that fit. But this is primarily what we're going to talk about in this class. So a few other things about the class. We are not going to assume any type of programming knowledge. So we're going to learn whatever the syntax we need. We are going to use Python in this class, but we're going to learn the syntax, along the way. And that way, if you have to redo this or build your model, the company you're working for does everything in R or does everything in Go, or just, has their own, uses a software package of some sort, then you will still be able to apply everything that you've learned here, and you'll know how to convert that to whatever language you're using. Okay. All right. So with that, what we're going to do is we're going to quickly go into our first task that was assigned for today. So hopefully everybody was able to get the data and build a predictive model. The objective of the task was to take that data, this was tips data, and then build a prediction for, can you predict the amount of tip that we're going to get, right? So let's go ahead and look at that data first. So it's always a good idea whenever you get data to be able to look at that data to see what columns exist in that data. Sometimes you might not be able to open it in Excel. You might have to open it using Sublime or Visual Studio or some other more basic notepad type of application. But either way, you really want to be able to see what columns you're working with and what type of data that is before you start doing anything. Okay, so in this case, we see that we have data for every row in the data. So the first one here, it was a female that came in. She was not a smoker. She came in on a Sunday. She came with one other person, and they came for dinner. They spent $17, and they offered a tip of $1, right? So the tip is exclusive of the total bill. So they paid $16.99 plus $1. Okay. All right. So that's kind of how we read the data. So now that we want to say, okay, we want to predict the tip, right? That's what we want to predict. So before we go and do any type of modeling, the first thing that comes to mind is that, tip is probably a function of the total bill, right? We kind of have an idea that in general, you're going to tip, the general 15, 20% or whatever, that essentially might be a driver of tip. So we see that, all right, maybe we'll want to use total bill to predict tip. But also, maybe size. We also have heard that whenever there's a size of, X or more people, 6 or more sometimes, then, a minimum tip is assigned. So in layman's terms, we might say, yeah, we predict tip based on bill and size. We don't know whether time of day or meal time or day, whether they're smoking or not, or whether the sex would affect the tip. So in a typical process of what we would do is we'd try to build a regression model, right? This is purely based on what we already know. We already know from the past that you can build regression models to predict something. Linear regression would be the simplest way. Why linear regression? Maybe because we know that tip is usually a percentage of your bill at the end of the day. So that's what is leading us to believe that maybe linear regression might be a decent starting point. Okay, so let's go ahead and do that for this tips file. So if you haven't already installed Jupyter, then you should install. You can use Jupyter to be able to write the code if you want to follow the code in class. Otherwise, you can go ahead and write the code in Visual Studio or some of the other IDEs that are available out there. Okay, so we're going to use Jupyter here. So I've already downloaded Jupyter, and I have opened up I did it through Anaconda, and through Anaconda I was able to come in and open up the notebook, Jupyter localhost notebook. And if you switch to /lab, it'll give you sort of this lab view. Okay. And if you have any other questions on that, we can talk about it after class. All right. So let's go ahead and get started right away. So first of all, we want to load the data. And again, remember we said we are going to assume that none of us know anything about any programming language, right? That's where we're going to start. So it might be a little slow for those of you who already know Python and who already are familiar with some of these tools, but I'm going to start from scratch for everybody else. All right. So we know we're using Python. That's the kernel here. And we want to load data into Python, right? So we're going to be doing a lot of this. So you're going to say Python data table. We're trying to pull in a data table. Let's see, Python load data. So we're going to be load data from CSV. That's what we want to do. There's a read CSV. And when you look at it, so it's using a library called Pandas. So Pandas data frame is a library, popular library, and it's a pd.read CSV. Okay, so we're going to be doing a lot of this where we copy, code, and paste because we're learning syntax along the way, right? So I'm going to be doing a read CSV, and let me take my import pandas, which is my library that I have to have. I'll put that here. Okay, so I'm going to import pandas as PD, which is my library, and I'm going to load my data. So let me call it tips, and I'm going to do pd.read.csv, and I'm going to give my file name now. That's tips.csv, and now I'm going to have to navigate to where my file was, right? So in my case, my file is, I'm going to have to go outside of this folder where I am in the notebooks file, up into my class folder, and then into data and into tips, and that's where my folder file is. Okay, so what I'm going to do here is I'm going to navigate out, and then into data, and then into tips, and then tips.csv. Okay, so this is how I'm going to load my data. All right, let's see if that works. So I'm hitting Shift Enter to execute this. You can also hit this play button up here. All right, so it seems like the data has been loaded. Let's see if we can take a look at the top few rows of this data set. So now we know that we're using pandas. We say pandas top few rows. So it seems like there's something called data frame.head. So if you see whatever your data frame.head is, it gives you the first few rows of the data frame. All right, so let's look at that. Head. All right, so we are now seeing the top 5 rows here. If we give it a different number, you'll get the top X number of rows. All right, so we are able to load our data, and we are able to see the columns, the values, and all that. But it would be nice to describe the data in some way, right? You know, what are the ranges of values for tip? What are the ranges of values for the bill? You know, and things like that. So if we say pandas describe data, so there's a .describe function, and okay, so there's a .describe. So if we go with df tips.describe, by the way, I'm not going to do this for every single task. This is the first one, which is why we're sort of starting from scratch. All right, so when we said describe, right away we get basic statistics. So we see that there's count is the number of rows in your table. By the way, pandas only reads, you know, tabular data. If you want to take in JSON data, there's other ways to bring that in. All right, so 244 rows in the table. The mean bill is $90 or almost $20, with a mean tip of $3. So it's about, you know, about 15% right there. And then you've got standard deviation and max, right? So the highest bill anybody has paid is $50, and the highest tip anybody has given is $10. Minimum tip was $1, right? And then so biggest size group here was 6. So this gives us a description of the columns, but we only see descriptions. Notice that the descriptions are only for the numeric columns. You've got total bill, tip, and size. But what about these others, right? You know, how many days do people come in here? How many different types of meals are there? So back here, we saw that, you know, when we did the .describe, it automatically gives all the numeric columns only. But if you say include equals all, then it gives you the others as well. So if we go back here and say, all right, I'm going to, let's add that, say include equals all. now we're getting descriptions of the others as well. So if we see, smokers are yes or no, sex is male or female. Day is, there's, 4 different days, which is good to know, right? It's good to know that this restaurant is only open 4 days in the week. And then there's maybe only lunch and dinner, right? So, so the dot describe kind of gives us some basic statistics without us having to do each of that by ourselves. All right, so like we said, and so, by the way, these are Jupyter notebooks, and so we really want to have inline documentation. So I'm going to be doing a lot of this. So we'll just call this initialize, and up here you can switch from code to whenever you're doing some documentation. Okay, so this is the initialization section, and then we were loading data. So let's go ahead and add that. Okay, so then here what we're going to do is we're going to, from our historical knowledge, we know that maybe fitting a regression model might help. So let's go ahead and do that. So let's say we're going to fit a regression model to predict. All right. And just like we went and learned the syntax all the way here, let's go ahead and do the same thing. So we want to say Python linear regression. So we see that there's a library called sklearn, and it has a function within that called linear model. So see if we can find an example here. All right, so there's a data set here. I use X and Y, and it is looking for sklearn.linear model and then linear regression. So let's go ahead and borrow this code right away and use it to for hours. Okay. Actually, before we do that, let's do that. So we see that, okay, I have my X column and then I have my Y column and all of that. And I know how to call linear regression. But the thing is, I didn't set my X and Y yet for my data, right? I need to set X and Y. And what I want let's start with the Y, which is my, my column that I'm trying to predict, which is tip. So I need to set it to tip. So that means I need to set my X and Y. So let me go ahead and do that up here. Let's say assign independent Y and independent X variables. So I'm not going into too much detail today on the actual regression itself, because I'm assuming this is something that we would have already known before we came into this class. But if you didn't know, that's fine. Regression is typically the simplest, easiest thing that you would do first anyway, whenever you're trying to predict something like this. So now I want to say X equals something and Y equals something, right? I want to set my columns based on, so I want to say X is my total bill and my size, because maybe I'll just use the numeric ones for now, and my Y is my tip, right? So how do we do that? Let's go to pandas, get column. So this is something that sometimes gets a little confusing when you go and try to do this on your own. But this is how I would recommend doing it. So when you go down here, let's look at a data set and then see. All right, so here's a data set. Here's a sample data set, right? It's got, dates as the rows, and then it's got columns A, B, C, and D. And now, let's see how they are able to pull out certain columns. So when you say df data frame, and then you put a list inside, and then say give me columns A and give me A and B, it automatically gives me columns A and B. But now another way to do that is, because this is assuming you want all the rows, another way to be a little more explicit is to put the dot loc. Okay, when you put the dot loc and you say give me what rows and what columns, that gives you the same thing. But by doing it as dot loc, this is a very standard way that you're always going to be able to do it, right? So sometimes you won't be able to do this if you only want some rows. And then there's the index method of also pulling it. But let's go ahead and do this. So we basically know that we want all rows and certain columns, right, for both of our X and Y. So let's take that piece of code. And so for my X, I want df trips, and I want all rows, and I want total bill. I also want size. And for my Y, I only want tip. So I'll just put tip here. Okay. So the way you read this is you have a data frame. You want called .loc. What rows do I want? So colon means all rows, and what columns do I want? Right? And I put that as a list. So if I only have one, only one item in that list. If I have multiple, so anything that is in brackets here is a list, right? So we have X and Y here. Let's see if that runs okay. All right, let's check that. So how we check it is now we look at df, we look at X head. Remember we called the head function earlier. All right, it's got total bill and size, and then we do Y head. Yep, so it gives me those. Good. So we got our X and Y. Now we can go ahead and call this. We're going to say from sklearn linear model, import linear regression. We already have X defined before. We already have Y defined before, so we don't have to do that. And then it says setting the linear regression, calls this, and then dot fit, calls the dot fit function, X and Y. By the way, don't worry much about the syntax. We just copied and pasted it. We will go over a lot of this in detail in future. Okay? All right. So and then we're going to call the dot. Yeah, so the dot fit. All right. So let's go ahead and try to run that. That also ran. Now, sometimes you might get an error that says, hey, I don't know what sklearn is because you haven't installed it, right? In that case, you might have to say, you might have to install sklearn. And installation can be done directly from your notebook by putting an exclamation mark, which, or you can do what we always do. Let's say install sklearn in Jupyter. So here, you see this piece of code here that says exclamation mark pip install sklearn, scikit-learn. That's what you would have done if you don't already have sklearn. Okay, so all right, so we have sklearn. So we pulled in linear model, and now we've run linear regression and fitted our X with our Y. So now let's see how well this does. So what was the syntax for that? We want to know what the coefficients. So this one gives us the coefficients. This one gives us the intercept. And then this is predicting something new. So let's do that one by one. We want to first display the regression model. What's the output, right? So let's put some documentation here. So here what we're doing is fit linear regression model. And this is basically training the model. And then here we're going to say let's display the regression. Right? So this was the .coef underscore is what you call to figure out what the coefficients are. So let's go ahead and visualize that. So let's call the print function. This is the coefficients, and this should give us the coefficients. We could have gone and searched for the print function also, right? So all of this is searchable. So if I want to say display output in Jupyter, output in Jupyter. Yeah, I was trying to get the print function, but I guess that might be too simple for this. All right, so you put print, parentheses, and then anything that you want in text, put that in quotes, and then comma to separate out what you want to show, okay? So this would give me, let's run this and see, all right, it gives me coefficients, writes the word coefficients, and then puts the, so this is in order of, so 0.0927 times the total bill plus 0.12959 times the size. So it's in the same order as X, but let's also print the intercept. So we go with that, and then we'll say comma, and sometimes if you don't know what the function for that is, if you just go and then hit tab, it'll give you everything that, you know, after the period. So you can see, so we know here that that's an intercept. Okay, so this is basically, right, so here what we're basically saying is that tip equals, let's write this as a comment. So tip equals 0.6689 plus 0.0927 times the total bill plus 0.1926 times the size. Okay, so that's how you would have read this, and then you can use this in, you know, your code wherever you want to use it to be able to predict. But then we can also now call the predict function, or however we, okay, it's called the .predict function, and then we give in the new bill. So let's say a new customer has come in, and so okay, let's call this new total bill is $45, and suppose the size of this group is 4. So now we want to predict what the tip is going to be using this model that was just generated there. So let's say print predicted tip, and then we say predict, right? And we knew that because we saw that here, .predict. Okay, and then we pass in. Okay, let's see what the syntax for that was. It's passing in a list of lists, so let's maybe use that. So whenever you're using code from outside, you got to remember that you also got, it also helps you see what type of format the input has to be in, which is not exactly obvious sometimes. Right. So I don't need NP array here. Okay, and now I want to bring in, instead of 3 and 5, I want to bring in my new bill and my new size. All right. So whenever there's a new group of 4 has come in, they spent $45, then their predicted tip is 563. Okay, and it's simply using this function that was generated through regression. All right, so this would have been the way somebody would have tried to generate the tips, had they not gone through some sort of, formal training and understand how to actually approach these types of problems, right? But it's still a way, a feasible path to take. And in your tasks, some of you might have gone down this path. Some of you might have done more complex models, simpler models, used Excel, use SAS, use SPSS, use some of these tools. But the objective of today's class is to tell you why going down this path may not always be the best path. Okay. Remember, we're teaching this course. This is an experiential learning course, so we're going to learn by making mistakes. And so if somebody had come in and said, okay, here's a prediction of tips, and you're the manager, you would wonder, there's, what are the effects of some of the other data points? And, we haven't, the big mistake we are making here is that if we go back to our notes here, we completely ignored the whole descriptive side and we went straight into the learning mode, right? We went straight into trying to make a prediction before we even understood what is happening with these tips. Okay, so a important thing to note here is that whenever you get data, you always want to go in and let's see what happens here. You always want to go in and view that data in a meaningful way. Now, so we really want to go and say we want to explore the data, and a lot of people go ahead and explore data within Jupyter Notebook itself. And there's nothing wrong with that. You can do that. But one of my pet peeves is people using, trying to use Jupyter to slice and dice data, which takes a whole lot more time than being able to do it through tools that have been there for over 25 or 30 years. And so what we're going to do now is we're going to go and take the same data file and do some descriptive data science on that data to understand what is really happening with the tips. Okay. Again, all of this can actually be done in Python. And if you're a pro at the libraries are matplotlib or Seaborn. So matplotlib is one of the libraries. Seaborn is another library. If you're a pro at that, or you like working with that type of language for libraries for visualization, great. It helps you kind of keep everything in one place, I guess. But for most people out there, it just takes too long, and there's no reason to write that much code just to come up with what you want. And eventually, whenever you want to share those visualizations, you really want that to be in a form that others can consume. Right? So what we're going to do is we're actually going to do this in Power BI. So just bear with me while I bring up Power BI here. And by the way, Power BI is free. Power BI Desktop is completely free. Anybody can download and start using it. The only thing that you won't get is that you will not be able to publish your charts online. Okay, but everything else can be done. All right, so I'm going to breeze through this very quickly. At some point in time, one of the follow-up courses, we might be able to do a sort of an in-depth into data visualization with Power BI. All right, but I'm going in to get data. To my class, data, tips. And one of the first things that Power BI does is it pulls in the data and it asks me if I want to modify anything in the way it seems, it's looking at what the data is. If I was to go ahead and transform data, hit transform, then I can sort of switch to types and all of that. And this is a very simple data set, so we'll just go ahead and load it back right away. And so as it brings it up, one of the first things that we would probably want to do, so here you see all the columns here, column names. And so let's go ahead and try to create a histogram. Okay, so let's see, get a basic column chart here. And yeah, so just all right. So this is a column chart, and now, so if I had just here's where I put my, what do I want on my axis? What do I want on my values for this chart? But let me go ahead. But now you remember that I want to create a histogram of tips, right? So, but if I was just to bring the tips as my values, then I'm going to see. Okay, this is summarizing it. If I see, yeah, so this is a summary of all the tips, and then I can split that up by whatever I want. But what I want to do is I want to create a histogram, which means I need to break this up into buckets. Right? So one of the ways to do that in Power BI is that you need to create a group. Okay, so this is something non-obvious to somebody who might have used some other BI tools. So you create a group, and when you create a group, that is when it puts them into bins. Right. So the bin size here. Let's go ahead and see what's the distribution of tips by dollar. Okay, so 0 to 1, 1 to 2, 2 to 3, that kind of thing. All right, and now let's bring the tips into the values group. Hold on. So sometimes what it does is it tries to aggregate it automatically. So I'm trying to see. There's something called don't summarize. Let's see. Bring in the bins. Okay, maybe I'm not using the right chart. Let me do this again. So groups, bins, bin size is 1. Okay. And if I try to bring the tips in here. Oh, on the axis. Okay. It should have been, sorry. So I should have brought the bins to the axis. There you go. Let me try that with a different chart again. And then I bring the tips to the values. Okay, so that's better. So what we see here, so basically we should have brought the bins to the axis, to the x-axis, because that's what's showing 0 to 1, 1 to 2, 2 to 3, 3 to 4, right? And the values of the tips are what's showing on the y-axis, right? So here we are seeing that the tips are. It's not exactly it is skewed slightly to the left. And you do have a lot of tips down in the $2 to $3 range. That's not very interesting. So let's go ahead and see if we can break it down a little bit. more. So if we say, you know what, let's make the bin size, to the 10th of a dollar. So this is interesting, right? What we're seeing is that you're suddenly seeing spikes at certain points. You see a spike at $2, a spike at $3, and even sometimes you're seeing some spikes at half. So 250, 3, 350, 4, and then 5. So what this tells us is, it seems like people, seem to be rounding their tips to the nearest dollar or the nearest $half, right? And this is not that uncommon. It's just easy to calculate a lot of times for people instead of trying to do math in their head. This is also common when people are, rounding off. Sometimes people round off when they're pumping gas, right? They'll try to round it up to a dollar or $half. So this is an interesting insight that we didn't get when we were doing our regression, right? When we jumped into regression, we didn't get this. So this is something for us to know that, hey, people typically tip rounded to the dollar or rounded to the $half. So this is one piece of insight that we were able to get because we did visualization. And then now let's also look at, so I'm going to go ahead and do a different one. All right, so now let's just look at just tips versus the total bill and what does that look like, okay? Let's say I want my total bill on my x-axis and then tips on my y-axis. Okay, I don't want to summarize my tips. Total bill also don't summarize. Okay, so this is viewing total bill on my x-axis with tip, and you kind of generally see a trend, right? So if you go to this icon here, which is sort of like an insights icon, you go to trend line, you can say add trend line, and here it went ahead and added a trend line. All right, so got a red trend line going on here. So what we see from this is that, yeah, it's generally linear, but you see that when the bill is smaller, the tips are somewhat closer to the trend line, right? But then as the bill gets larger, the tips get, more off of the trend line. And also, as the tips get larger, as the bills get larger, the tips are actually more lower than higher, right? You see a lot more on this side than on this side. So, in other words, people are more, cheap than being generous, right? As the bills get larger. So that's another insight to kind of, consider. As the bill goes higher, maybe we don't want to overestimate what we're going to get because it seems like there's more going on the bottom of that line, right? And then one more thing we want to see, okay, what's the effect of male versus female and smoking versus non-smoking? So I'm going to take a few minutes here and create 4 charts. I'm going to replicate this chart. Let me create a copy here, page. And then I'm going to replicate this for male, female, and smoking and non-smoking. So just bear with me for a few minutes here while I do this. Okay, I'm going to do that. And this I'm going to filter by, let me put some labels first. I'm going to bring the text box. It says, is female. Right. And let's go ahead and put that female, and then we're going to just applying some filters, and it helps to kind of see them side by side, which is why I'm doing it this way. Okay. And then I also want to do smoker and non-smoker. So Okay. Smoker equals no. So non-smoker here. And okay, smoker equals yes. So now by these filters, so here I'm going to apply sex as a filter here. This is how I do it. Sex is female and smoker is no. That's my combination, right? Female and no. And now I'm going to repeat this for, so this is smoker and yes. Sorry, female and smoker is yes. Right, and then now this is male and smoker is no. And then we'll take this one. Here, this is male and smoker is yes. Okay, so now you see that we have 4 charts. It's the same bill versus tip. You've got all the females in this column, males here, non-smokers and smokers, right? So let's take a look at that a little bit. So the first thing that we notice is that when we look at the bill amounts, you notice that here women seem to be more, in general, more women who are non-smoking seem to be very consistent tippers, right? So female non-smokers seem to be, very consistent tippers. They're very close to this line. On the other hand, males, as the bill gets higher, maybe slightly off, right? And then another insight here is that once somebody starts smokers, you see that they're a little bit more kind of off the trend line, right? You see for both men and women, women especially compared to when they're non-smoking, and then men to a slightly lesser degree. But so the variation in the amount of tip is higher when they're a smoking party versus non-smoking, right? So these are some insights that we were able to get. So the first one we got was that, hey, people happen to round their tips off to the $50, but mostly to the dollar. Then we also see that as the bill gets higher, people happen to be more cheaper. Female non-smokers are very close to the trend compared to the men, and then in general, smokers, the variation of the tips is much higher than the non-smokers. So all of this gives us other insight, right? So if we were to go back to our notebook, so we did all of this, and then we said, we did some visualization in Power BI. But what is our takeaway now from all of this? Our takeaway is that number one, you can document this in Markdown also. Let me just call it takeaways. So the first takeaway that we have, both first example model. But then we realized that descriptive analysis is very important prior to building any model. Okay, so that's the underlying takeaway from today's class, is that yeah, we could have gone and built used a machine learning model to go ahead and learn the parameters of all of this and come up with a prediction, even be able to make the predictions. And I mean, we can, by the way, we can look at the score. I think score gives you the R squared. I need to rerun the model to be able to get that. But in spite of doing all of that, we realized that whenever we did the data analysis, we found out some other insights which might have fed into better columns or smarter input into our prediction model, right? So by jumping into the regression model right away, we missed out on a lot. That's the fundamental takeaway. Okay. All right. So basically, whenever we are given a set of data and we are asked to go and predict something, the very first thing you want to do is say, yes, okay, but I'm going to first load it into some sort of a data visualization tool, and then I'm going to slice and dice that data, take my target, which is what we did here. We took our target, whatever we're trying to predict, and we built a histogram. What are the different values you get for that? And then what you build. This is actually what we just did here. This can easily be done even in Seaborn and some of the other ones. It's kind of a cross plot where you're cross plotting every column with every other column, and along the diagonal gives you all the histograms, and every cell in that table gives you one of these charts, and so it really helps you to figure out which columns primarily drive the output and whatnot. Okay. So what you really want to do is load the data in, study the columns, study the relationships between them, and sometimes you might be able to just come up with a prediction right there without even having to do any modeling. But then if you really do need modeling, then you can come in and then build a regression model or whatever model is appropriate for that. Okay. So from next class onwards, what we're going to do is we're actually going to go into machine learning models. Now that we've proved our point that you really do need to visualize before you do anything, we're going to move past that and say, okay, let's say we're here now. What are the things that we want to do?